In this question, it is given that for every twice differentiable function f whose domain is R, codomain is -2 to 2, with f0 square plus f dash 0 square equal to 85, which of the following statement is oblique R true? The first choice says that there exists R and S belonging to capital R, where R is less than S, such that f is 1 1 on the open interval R to S. Obviously, this is true. This is actually true for every non-constant continuous function, because the function is given to you as differentiable function, hence it must be continuous. And function is surely not a constant function, because constant function will mean that f dash x is 0 for every value of x. But f dash 0 cannot be 0, because if f dash 0 becomes 0, f0 square will become 85, which is not possible because the value of f0 clearly lies between -2 and 2 from this information. Hence f0 square mod will be surely less than equal to 4. Hence f0 square equal to 85 will become impossible if I take f dash 0 as 0. Hence f dash 0 cannot be 0. That is, the function is not a constant function. And if the function is not a constant function, and as the function is continuous, that is, the graph of fx not be always parallel to x-axis. Say there is an interval r to s where the graph is surely increasing. The length of interval can be taken however small. Hence, there must be some interval however small that the function is surely increasing or surely decreasing in this interval. And if the function is surely increasing in this interval, obviously the function will become 1 1. Or if the function is surely decreasing in this interval, in that case also the function will become 1 1. This must be clear to you if you know the meaning of the word 1 1 function. For making you understand this part, first I would like to make you this concept clear to you, that if say there is a function y equal to gx, and I take the interval of values of x as 2 to 5. 2 and 5 I have just taken arbitrarily. I can take any interval. I want you to make this concept clear to you, that if for all the values of x, g dash x is more than 1 for the values of x lying in this interval, then the length of interval of range of values of gx will be surely more than the length of this interval. Say this is 2, this is 5, say this is having y coordinate, say 3. I have just taken arbitrarily, and because the length of this interval is 3, I take the length of this interval also as 3 equal to 6 now. Slope of this line will be clearly equal to 1, that is this angle will be equal to 45. If the graph is such that the slope of tangent at every point in this interval of values of x, then it is sure that the final length of interval of range of values of fx will be more than this. That is, if it starts from here, it will be reaching somewhere at higher height than 6 if g dash x is having value more than 1, that is slope of tangent at every point is more than the slope of this line, then in that case the range of values of gx will be surely more than this length, because it will be finally reaching at a height having y coordinate more than 6. Similarly, the case if the slope of tangent is less than or equal to -1, in that case situation will be of the type, if the graph starts from here and slope of tangent is less than -1, in that case also final length of range of interval of values of y, which will be this length of range of values of y will be also again more than 3. Note that this interval has length 3, and hence keeping this concept in mind, I can easily say that this choice is correct, because if this is not correct, that is if at all points of this interval f dash x0 is greater than 1, in that case interval of values of answers of fx will be more than 4, but it is given that the range of interval of f has length 4, that is if for all values of x belonging to -4 to 0 this is greater than 1, then the values of fx will have to go beyond 2, which is not possible. Similarly, if it is less than -1 for all these values of x, in that case also the values of fx will have to come below -2 also. Note that this interval has length 4, this interval also has length 4. Obviously, if g dash x is greater than say 2, in that case the length of range of values of gx will be surely more than double the length of this. That is, if this length is 2, then the range of values of gx will have length of interval more than 6. It's not difficult to think. Hence, if for all x belonging to -4 to 0, this is greater than 1 or less than -1, will be reaching at contradiction. Hence, B becomes correct choice. Otherwise, I can prove this thing very easily using Lagrange theorem also, because according to Lagrange theorem, in the interval -4 to 0, there is at least one number x0 such that f dash x0 is equal to f0 minus f minus 4 upon 0 minus 4, and this implies that mod of fx0 is equal to mod of f0 minus f minus 4 upon 4 mod, which is less than or equal to mod of f0 plus mod of f minus 4 upon 4, which is less than or equal to 2 plus 2 by 4 equal to 1, because the maximum value of mod of f0 is 2, because codomain of the values of f is this. Similarly, I can prove there is a number x0 dash such that f x0 dash mod is less than or equal to 1 for x0 dash belonging to the interval 0 to 4. C choice is very easy to see that it is wrong because you can easily think infinite number of functions for which domain is set of real numbers, codomain is -2 to 2, and this condition is also satisfied and limit is not 1. See how. I draw a line through -2. Keeping this information in mind, I will draw a graph which lies in this portion only. And to make this condition satisfied, say the value of f0 I take, say 1. 1 I have taken arbitrarily. That is, the graph is passing through this point. And to make this condition satisfied, I can draw the graph in such a way that the slope of tangent at this point becomes under root 84. If I take slope of tangent at this point as under root 84, then this condition will also become satisfied. That is, if I draw the graph such that it always remains in this interval and satisfies the second condition, we can draw infinite number of graphs, say it is obvious that in this graph limit x tends to infinity is 0. This is the case in which limit is existing. Otherwise, I can make the graph such that even limit does not exist also. That is, if I go on fluctuating the graph in this interval, then limit as x tends to infinity will not exist. Hence, it is very obvious to see that it is clearly a wrong choice. Now the next part is to check the truth value of D choice. And while doing practice of questions of JEE level, you must have seen that in most of the questions in which we have to check or prove, there exists at least one number alpha belonging to some interval such that some equation is true. We have to use the concept of Rolle's theorem or Lagrange's theorem or intermediate value theorem. The same thing I will be using here. I will be doing this part of the question in two ways. And you must have seen this thing also, that for proving some equation equal to 0 with the help of Rolle's theorem or Lagrange's theorem, we always take a function gx which is integral of fx, and so that when I put g dash x equal to 0, I get fx equal to 0. I have told this thing in rough language, but you must have understood if you have done practice of the questions of Rolle's theorem or Lagrange's theorem. Hence, to prove that there is at least one number x such that f double dash x is 0 for x belonging to -4 to 4, as I just now told you, we'll have to take a function which is integral of this. That is, we'll have to take some function and name it gx and take the interval as -4 to 4. But using this direction to solve is very difficult. Hence, the other possibility is I take the function hx which is equal to fx whole square plus f dash x whole square. Note that f dash x will become 2 f dash x into fx plus f double dash x. This part is same as this part. And now how I am going to proceed? See, it is clear that the value of x0 is 85 because it is given to you as 85. And we know this thing also, that in the interval -4 to 0, there exists a number x0 for which f dash x0 will be less than or equal to 1. Hence, I can say there exists a number alpha in this interval such that h alpha, which is equal to f alpha whole square plus f dash alpha whole square, the value of this will be less than or equal to 4 plus 1, that is 5, because the value of f alpha is sure to be lying between -2 and 2. Hence the maximum value of this can be 4. Means we have found a number in the interval -4 to 0 such that h alpha is less than or equal to 5. Similarly, there is a number beta belonging to the interval 0 to 4 such that h beta is less than equal to 5. And because x0 is 85, that is h has attained y coordinate 85, h has attained y coordinate less than 5 for these values of x, and h has attained a value less than 5 for these values of x, then I can easily say that the graph of hx for the values of x -4 to 4 will be having some local maxima at some point, say lambda, where y coordinate is greater than or equal to 85. That is, there is at least one number lambda in this interval say that h lambda is greater than equal to 85, and because it is a point of local maxima, hence h dash lambda will be 0. And keeping this thing in mind, I can say h dash lambda is equal to 2 f dash lambda into f lambda plus f double dash lambda. And because h dash lambda is 0, it means we have found a number lambda in the interval -4 to 4 such that 2 f dash lambda into f lambda plus f double dash lambda is 0. But f dash lambda cannot be 0. From here I can say h lambda is equal to f lambda square plus f dash lambda square, and if I take f dash lambda as 0, it will mean that h lambda is equal to f lambda square, but we know that the value of h lambda is greater than or equal to 85, and the value of this is less than or equal to 4. Hence we will be reaching at contradiction if I take f dash lambda as 0. Hence I can say there is a number lambda in this interval such that f lambda plus f double dash lambda is 0. Hence I can say D is the correct choice. Otherwise, to prove the choice D, I can use Rolle's theorem also. To prove this by Rolle's theorem, as I proved in choice B, there is a number alpha belonging to the interval -4 to 0 such that mod of f dash alpha is less than or equal to 1. Hence I can say there is a number alpha such that H alpha, which is equal to F alpha square plus F dash alpha square, and because the value of this is sure to be less than or equal to 4, the value of this is sure to be less than or equal to 1, that is the value of H alpha will be surely less than or equal to 5. That is, we have found a number alpha in this interval such that H alpha is less than or equal to 5. Similarly, there is a number beta in the interval 0 to 4 such that H beta is again less than or equal to 5. Suppose P is a number in the interval -4 to 0 where the function has attained the height 5, that is Fp is 5, and Q is a number between 0 and 4 such that HQ is 5. And here I am supposing that P is the last number while going from -4 to 0 where the function has attained height 5, and that is after this point the graph is going on increasing and reaching at the height 85 because h0 is 85. This is the graph of hx I am going to draw, and this is 4, and q is the first number while going from 0 to 4 when it has attained the height 5. That is, I mean to say, between P and Q, the height of Hx is always 5 or more. Then according to Rolle's theorem, there is at least one number lambda such that H dash lambda is 0. And H dash lambda equal to 0 means F dash lambda into F lambda plus F double dash lambda equal to 0, and the value of lambda according to Rolle's theorem belongs to the open interval P to Q, and this is subset of -4 to 4. And because I told that between P and Q the value of Hx is always greater than 5, and keeping this thing in mind, F dash lambda cannot be 0 because H lambda is known to us that it is F lambda square plus F dash lambda square. If I take F dash lambda as 0, I will be getting the conclusion that H lambda is equal to F lambda square, and this is greater than 5, and the value of this is less than or equal to 4, because according to given information the value of F lambda lies in the interval -2 to 2. Hence, reaching at wrong conclusion means that I can't take F dash lambda as 0. Hence, we have concluded that there is a number lambda belonging to -4 to 4 such that F lambda plus F double dash lambda is 0. Hence, I can say D is also correct. That is A, B and D are correct choice.